See,
Wait, so which?
Leah and me. Yeah.
Hi, Mr. Pagano.
Okay, so you want to start off with a problem like this. You start off with 372 joules of heat. So you put that as what it's equal to. So put 372 somewhere over there.
But which formula are we using?
You use the one that's from converted. So it's assume that 372 joules of heat is added to 5 grams of water originally at 23 degrees Celsius. What would be the final temperature of the water? Specific heat capacity of water is 4.184 per gram. So you'd start off with it's the one where you have the Q equals MC delta T. So
really? It wouldn't be the PV over T over N.
No, it's the Q equals MC delta T. And so you start off with 272J, and that's equals, put equal sign.
Equals.
And 5 grams times the specific heat of water, which is 4.184.
4.184
times the change in temp,
which is
23 degrees Celsius, which was originally 26. What is the final temperature? But you put that as X.
Okay.
Because you don't know.
Okay, and then we'll multiply.
You solve for X.
Yeah. Okay. So then 5 times 4.184 equals 20. Okay.
And then,
so then we'll divide this by 20.94 because that's what it equals. 20.94, and then X will equal 372 divided by 20.94. X equals 17.7.
okay, so now since that's the change of temperature, because delta T stands for change of temperature.
So what's the final temperature? So we
add
have
23 to that, and I'll get you your final.
But if you did it, you're totally
40 point.
Alright, final temperature T equals 40.8.
I just like studied
what else do you need help on?
Okay, let's see. Can we do number? Okay, I did not learn that.
Yeah, it's like that stuff.
Let's do.
Do you know the difference when you use specific heat with joules to grams and joules to moles?
No.
Okay.
Can you teach me that?
Okay, so there's some examples where you're going to need, it's kilojoules a mole, the heat of vaporization. So you need to convert everything to, it has to be moles first, but not the grams, so you don't use the grams. So the way you do ones like that is since there's 12,500 joules of energy is added to 2.0 moles, you got to think of it like a graph in a way. All that. Okay. So you have frozen right here. This is where the ice sample's at. Then you have level off, and the mole heat of fusion is 6.02. So that's your change. So you first got to get up to here. Then you go to 6.02, which goes to water.
Oh, okay.
And then from water, it goes up till you get to 100, and then vaporization is 40.6. So there you convert to vaporization. And so the idea is you're supposed to get rid of all this energy and find out what state of matter it is in.
Okay.
As you can see, I already solved this one, but how do you, so first you would take 12, you take the moles, so added 2 moles of H2O, so 2.
Well, wouldn't it be like E equals MC delta?
It's Q equals MC delta T. That's the same equation as last time.
Equals MC delta T.
Yeah,
Okay,
so you start off with, Q is not given, you're trying to find Q. So you start off with
equals the mass, which is...
the mass is going to be 2 moles, because we're using 2.
Okay. Well, wouldn't we use 36 grams? Because...
But since it's kilojoules a mole for the
okay.
thing,
So just
and it's at an ice sample at 0 degrees Celsius. So you go 2.0 moles
2 times
the heat of fusion, which is 6.02.
6.02 times.
That's it. So you solve that first.
Okay.
And,
which is 12.4.
So that's the amount of energy it takes to melt to water. From there, you go up to from there you do another equation, which
you
is
multiply it by 100. Right?
2 times the specific heat, which is going to be 4.18.
4.18